So this one says solve each system and explain the method, explain why you chose the method that you used. So I've solved all these out. I'm going to plop in my total solution and then zoom in on them one by one and talk about them. Okay? Um, okay. So for this first one, and you can choose any method that you want. I'm just going to show you what the solution is and what I chose to do. Okay? So on this first one, when I look at this, I notice a couple of things. I was originally thinking about graphing because these are both in standard form, but I know that when I graph, if I set, for example, I put 0 in for x right here, and I just get 5y equals 3, then when I divide by 5, I'm going to get a fraction, y equals 3/5. Once you start trying to plot fractional amounts, you're going to not really be in the exact spot. It's hard to get it exact if it's not whole units. And then where they cross is not necessarily going to be easy to find. So I decided not to do that method. And because um, there was no obvious way of solving for one of the variables neatly, I just decided to do elimination. So this is what I did. I said, okay, I'm going to try and get the same amount of the y's on both of them. There's 5 y's here, and there's negative 2 y's here. So the common multiple of 5 and 2 is 10. So I said, okay, well, if I multiply this whole equation by 2, which I did right here, then I will get 8x plus 10y equals 6. Okay? And then if I multiply this by 5, negative 2y times 5 is negative 10y. Now I've got a 10y and a negative 10y. So I multiplied this equation by 2 and this equation by 5 so that I had two equivalent equations that had exact opposite amounts of y. And then I added them together, and let's see if I can zoom this here. Oops. I added them together, and I got, sorry about that, I got 23x equals 46, and then solving I get x equals 2. Then I was able to just plug in that 2 and find out that y was equal to negative 1. So then I get a solution of 2 comma negative 1. Okay, that's what I did for that one. That just seemed to be the best way for me to do it. Now, for this next one, and I'm going to zoom in on this one. I'm sorry if the zooming in and out is kind of, challenging to view, but I see that for this one, we've already got one solved for y, so that makes it easy to do substitution. So I take the 2x plus 7y equals negative 20 right here, and where I see y, I put in what y is worth. Now, doing this, you then get down to just an equation with, so sorry, I'm trying to switch back and forth between tools. It's not always seamless. You get an equation with just x's, and then when we combine all the like terms, move everything to one side, we find out that we get x equals 3, and then, of course, substituting that in, x equals 3, we find out that y equals 2, and we get negative 3 comma negative 2. So that one seemed best suited for substitution because it was already solved for y. Okay, now zooming in on this one. Again, I'm sorry about if it doesn't make you too nauseous. This one doesn't solve nice and neatly in terms of, in terms of what the numbers work out to be. We get fractional numbers. But, and in fact, if you look on the book, on the answers on that lesson page, it says possibly substitution because it's easy to solve for x. You could just add 2y to both sides. That wasn't my choice. My choice here, I saw that there was 2y and negative 2y, and I decided to just do elimination by adding them together. 5x plus x is 6x. These two go away, or these y's go away, and then this becomes 25. So then when I divide both sides by 6, we get 25/6. Not a nice, neat number. And of course, when you substitute that in, you get another fraction resulting. But it's really about what method should you use, and I found the best method would be elimination since these had opposite coefficients on the y variable. So I will zoom back out. I will let you examine those solutions, but really you're picking your favorite one and whatever seems to work best for you. So that's what I did to solve mine. There you have the solutions, and you can figure out what you think would have been